Kia ora. I'm Jennifer Brown and I'm a Professor of Statistics at the University of Canterbury. And my area of research is environmental statistics. And the thing I'm interested in environmental statistics is environmental monitoring. So what that means is we're all interested in having a nice, clean, green environment. And the question is, how do we know? How do we know that we've got a good, clean, green environment? So for example, in New Zealand, we have some very iconic species, plants and animals, which are endangered. Their numbers are going down. And so we need to take management action, conservation action, to try and stop the counts or the animals and plants reducing in numbers. And at the same time, we've also got introduced animals and plants, weed species and pest species. And again, we take management action to try and ensure those numbers are kept as low as possible. So there's a lot of work being done in New Zealand, a lot of money being spent on conservation and in management in general, trying to either keep the invasive, the introduced animals and plants at low numbers, or try and encourage our native animals and plants to increase in numbers. And so what monitoring's doing is assessing that. How good a job are we doing? And the question, like I said, is how do we know? So when we have very low density, like animals which are very rare, or we've done a great job at controlling our invasive weeds, most of the time when you do surveying out in the field, you don't find anything. So if you find you don't find anything, how do you know that there's nothing there? Now, it could be that there's actually one or two rare animals left, but we just fail to detect them. Or it could be actually that species has gone extinct. So that's what I'm interested in, is that environmental monitoring. How do you design work in the field so that it increases the chances of finding that very rare animal or plant? Now, they're either rare because you want them to be rare because they're invasive, or they're rare because we're not doing a good job at changing the track of extinction. So the question is, it's about allocating resources. So imagine you've got 10 people, you've got enough time for 10 people to do one day in the field. Do you put all 10 people out on one day searching for this rare plant? Or is it better to spend 10 days with one person searching for the rare plant? So how do you allocate that survey effort? And that's called survey design. So my research is looking at optimum designs for environmental monitoring. Do we go out every day in summer? And then if you're thinking about trying to track changes through time, how much effort do we put in every year? Do we put in a small amount of effort in summertime, not much effort in wintertime looking for these things, or do we put constant effort all throughout the year? So really interesting questions about how do we allocate that survey effort so that you're confident when you see a change that actually is the change that will really happening in the plant or the animal that you're interested in. So it's either going to be our native flora and fauna, which we want to stop declining, or it could be our introduced plants and animals, which we hope will be declining because we're trying to control them. So interesting questions about allocating effort. And it's all statistics, it's all probability. What's the chance of finding something if it's there? So it combines my interest in ecology and in conservation, as well as my interest in statistics and doing field work and making, hopefully, a practical difference in helping out New Zealand's clean, green environment.